Hello everybody. So today we're going to continue with the MATLAB. First of all, if you open the MATLAB, you will see three components: the folder, uh, your files. You put in the current so-called folder. Then you have a command window here where you type in all your coding. Then when you run it, everything will display in the workspace. Sorry, right? The workspace. Well, first of all, let's say we can just create a folder, okay, in the desktop. Let's say we can create this in the desktop. Or we can put something in the download. Okay, create a new folder here. Let's say MATLAB 01. Okay. So this is our MATLAB 01. So after that, we can just open the file and lead to the download just now, MATLAB 01. So we select this as a folder. So far there's nothing there. Okay. Let's say for coding, normally we prefer to write in the script because after this we can do a lot of modification or amendment needed. Okay. So just open the script. So now I under the editor now. Under editor, let's say we just save the file. Save as this is a folder name. Let's say this is time series 01. Let's say, okay. So this is our top end file. Okay. To save it, then you have ts01. Right, ts01. So from here we can start writing the coding. So first of all, we have so we can make a statement here. So what is this coding is about? Let's say financial time series analysis. Okay. So in order to clear everything inside the workspace and command window, so we can use the clear and then CLC for the command window. So after that, let's say first of all we want to load the data. So let's see what are the data available in the MATLAB. So this is data sets and examples, I would say. So there's a documentation here which is quite useful. You just enter and have a look. So this is under MATLAB documentation. So you can see the data set and examples. This is under the econometrics toolbox. It's when inside your PC or inside your laptop already. So here you can just load the data set available is all this. For example, the Canadian inflation and interest rate 1954 to 1994. So we can choose any data here. Let's say we just select, you can have a global index. So maybe we just start with the data equity index, which consists of a US equity index from year 90 to 2001. Okay, so you can just go back to this. And then let's say we're going to load the data. So just now we copy this. So let's say we just run this and have a look. We go to run. So this is our first script now. We just run it. Then you see everything will display at the workspace here. We consider data, data table, dates, description. So let's see what is this data set about. So it's an equity data set consists of two series with a total observation 3028. Okay? So this is maybe 15 years data set. So you have NYSE, the first series, the data close index, the NASDAQ daily close index. So there are two series here on the source. You can actually get it from the website here. So if you look at the data set, first series is the NYSE from 1990 to 31st of December 2001. So total of 3028 observations. Okay. So the other series will be the NASDAQ. Okay, it will be a NASDAQ. So we just close this. So let's say we want to extract the price. Okay. So we create a variable called price NYSE. Then we're going to use, so the data actually just now is from the data table. Okay? So under data table, so we have two series. First one is the NYSE, the other one is the Nasdaq, is it? So this is the code for R. So this one we use equivalent. So we assign the data set to a variable called price NYSE. Right? So just now that is R syntax. This is MATLAB using equivalent sign. Right? So then we have already generated the price index. If you want to see, you can just run it and you see the price index is here. So this is the first series NYSE. Right? So then we also want to generate the return series, which is return. You can use any variable or name you like, as long as it is. So if you want the percentage, then we just multiply 100. Right? So we just use a function called price to return, convert price to return. Okay. So price to return, then the series we're going to use is the price NYSE, isn't it? Just now, right? So then you run this, then you get another series called return NYSE. Okay, this is a return series. So we have price and return series already. So after that, let's say we just have a quick plot of so this one you can make a statement if necessary. You make a statement, then you say this is convert price to return. Okay? When anybody read your code, then they'll read that statement and understand what is going on here. Okay? So after that, let's say I want to plot. So the function is called plot price NYSE. Then you will plot it. So then let's say I want a title. Okay, let's say we just run it first. Then you can see the plot is here, isn't it? Right? The plot is here. Then we can have the title. Let's say, so this is the title. We just put in a price. Okay, NYSE price index. Okay. Okay. Then we have X label. So X, what do you going to label? Is a daily data, isn't it? Daily index. Sorry, daily basically is daily. So for the Y label, we're going to have NYSE or just price index. Price index. Okay, now we run it. And your series now is with what is the Y label is price index. How come there's no? Let me check again. Run this one more time. Why? Oh, sorry. There's an error there. So if there's an error, then the command window will alert you. Okay, Y label should be is wrongly spelled. Okay, therefore it will not indicate. Okay, so you look at the command window, then you should be able to see. So run this one more time, then you should see this is the price index, this is daily data, and this is the NYSE price index. Okay, so the similar way you can do is I can plot the return series, return, then this is NYSE return series, let's say, then this is return series. So in order to display both the graph, then you just use the figure here. Okay? Else the MATLAB will only display the latest one, okay? Which is the returns only. So you put a figure, you display both. So then you see two graphs here, price and returns. Okay, price and returns. But somehow it is good for us to put two graphs together in one. Okay, then you can use a subplot here. Okay, so you use a subplot. So you want to have returns is update or price is up there, return is at the bottom. So you have a matrix which is 2 row, 1 column. Then the first graph, okay? 2 row, 1 column, the first graph. So this one basically you can just display this everything here, and then let's say we can just put all this as a statement, right? You change everything to statement. So do the same thing for the second plot. For second plot, we just use subplot again. So now the second graph, this will indicate the second graph. Okay, second graph. So here we just use the same function for this. Okay, so this is sorry, the second one should be returns. So this should be returns. So 2, 1, this should be returns. Okay, this should be returns. Okay. Okay, so this one we just put it as a statement. Okay? So in this case, we can plot 2 graphs in one, where this is how the graph with price and indexes. Okay, price and indexes. So in this way, you can just have a look at there's an upward trend over the time. Then when there's a up and down trend in this region, you will see the fluctuation is much intense if we compare to this one, isn't it? Okay, so this is the so-called leverage effect, okay, for time for financial time series. Okay, so this will be a quick analysis of time series here. Okay, so in order to understand the, let's say we go to another part which is called the descriptive statistics. So we want to have a look at the descriptive statistics. So very fast we can see the mean, the variance, the skewness, the kurtosis. So this will be the 4 measurement of to see the distribution of the graph. Okay? So let's say I use a function, I use a variable called y, then I just put the mean and median, have a look at it. Mean for, let's say we want to study the return series. Okay? Next one is the median. Just make a comparison. Return. Okay? Another series is okay. So we can just run and have a look at the command window. So the mean and median is basically quite close to each other. So in other words, we might say that the mean and the median with such a close value indicated that the distribution is symmetrical, okay, or symmetrically distributed. Okay? So this is our first guess of the distribution. Okay? So let's say the other measurement is the skewness, and the skewness is this function. We just study the return series as well, or we can just use it for return series. Okay. So the second measurement is the volatility, let's say. Sorry, the kurtosis, sorry. Okay. So we also want the return series as well. So after that, we can just display this. Display this. So we have a skewness. Oh, sorry. This one shouldn't be. Okay. So you see the skewness is negative skew. Okay. So that means it's skewed to the left now. So the magnitude, of course, somehow is still hard to determine how strong the skewness is. So I think with this value, it is not too strong, but somehow there are more observation at the skew to the left, means to the right hand side is more than the or there are some outliers at the left tail. The other one is kurtosis 7.920. So this indicate heavy tail, or there are larger thickness okay, as compared to normal distribution. If for normal distribution the kurtosis is 3, so this is the excess kurtosis actually is 7.9120 minus 3, which is 4.9120. Okay, so this basically is the first glance of the distribution. So the easier way is you use a box plot to have a look at this one. Okay, so the returns NYSE. So the box plot can give you an overall review. Okay, sorry. I think this one we can just the subplot actually cost. So this one we just use the figure and display again. So from this box plot, we are able to see that there is quite a number of extreme values which is are in the potential outliers. Okay, so this often observed in a financial time series. So your Q1, Q2, and Q3 is in this position. So this is the 1.5 times IQR, the interquartile range plus the Q3. This is minus the Q1. Okay, so you have quite numbers of observation. In other words, it is symmetrical, okay, according to this box plot, and there's a lot of observation at the right tail and left tail as well. Okay, so that will be our guess for this NYSE returns. Okay, NYSE returns. Okay, guys. So we'll end this session, then we continue.